remember that with almost every lesson that we do, and we're have like multiple steps, there's always an explanation of what we're doing. Okay, so starting with, or whenever you're stuck, whether that be in class as you work through an example, or when you're at home, okay, doing the homework, and you're stuck, don't be afraid to read these explanations out. In fact, if you can understand and use language around the math that you're doing, that's a really good way to build long-term learning habits. Okay, and so that when you learn this year, you don't forget it next year, right? That happens a lot with math. You're like, oh yeah, I knew it for about a week, but I forgot it. Okay, but if we attach language, like what you see over here, to everything that you're doing, now these things stick in your brain long term. So now, with equation 1 here, I'm looking at the equation as is, and I can't add anything together, and one of the variables eliminates, right? Negative 6x, 9x won't eliminate. Negative 12y, 18y won't eliminate. I'm also recognizing that I can't multiply 6 by any whole number to get 9. I can't multiply 12 by any whole number to get 18. So this is probably an equation or a system where I need to multiply both equations. Okay, so how do we choose what to multiply by when it's both equations? You'll always start with which variable do you want to eliminate. And it doesn't matter which one you choose. Okay, usually, again, what I think about is which one has these smaller numbers. Okay, that'd probably be the x's. And so I'm looking at this, and if I know that I want the x's to be the same, what I can do is take how many x's are in the bottom equation and multiply the top by that amount. So I'm going to take this whole top equation, multiply it by the number of x's I have in the bottom, which is 9. So that's going to give me negative 54x. If I then multiply the bottom by the number of x's up top, so that'd be 6, that's also going to give me 54x. And the only other thing I need to make sure happens is that we get opposite signs. I'm going to get negative x up top, positive x on bottom. Okay, so now we're on our way. We got a lot of multiplying to do. So 9 times negative 6 is negative 54. 9 times negative 12, I think, is 108. So minus 108y, then equals 108. Then 6 times 9 is 54x. 6 times 18, that'd be 6102. 6 times 18, 108 again. Oh. And then 6 times negative 18. I just did that. It's 108. It's negative 108. Okay, and the whole reason that I picked the 9 and 6, or at least what I was kind of hoping would happen, is that the x's would eliminate. But by multiplying by 9 and 6, I also get the y's to eliminate. And so that whole left side is 0. The whole right side, 108 and negative 108, also eliminates, and I get 0 equals 0. 0 equals 0 is a true statement. And when we get a true statement, that tells us that our solution is infinitely many, so infinite solutions. And again, what that tells us about the lines is that they are the exact same. Okay. Everyone do number 2. Again, right now, I just need you to try number 2. Do your very best with it. You can skip 3. We're going to pick one more from the back. Ready, go. Just set up my computer right there. Let's get going with that now. And we're not. Come on, man. You didn't forget about math. Just not doing things that we're supposed to be doing. So this is why I get frustrated. Because this is the same lesson that you just missed, and you haven't written a single thing down. And that's where, if you ask for help, like if you're not doing the things that I'm asking to do, I'm not going to come back and do the things you want me to do for you. Does that make sense? Yeah. We're at. We're at. 35 negative 35. So that's 50. That's 70. Okay, that looks good. Yep.
And then I got.
Okay, so this 7 times 8, that's 56, but it's positive 56. You change that sign to be negative. So that's probably why. See if that fixes it. All right, Alan, pick a variable. Which one do you want to eliminate, X or Y? Okay. And I don't want you to erase everything because now we can just kind of figure out what went wrong. There's a lot of really good stuff there. Yeah. Good. 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 Yeah.
If your y is -3, you plug it into a different equation. 7x minus 7.
Yeah, you've done everything right. That means that y equals -3.
Yeah.
Okay, and I'll do that one last time with this last problem. Okay, but again, where do we start? We start by really, can we add them together and get x or y to eliminate? Right now, nothing's going to eliminate. Okay, so I've got to at least multiply one equation, maybe both. How I decide is, can I multiply one equation to get one of the variables to match up? Well, I can't multiply 5 by any number to get 7. I can't multiply 8 by any number to get 7 and vice versa. So if I can't multiply just one, this is where I need to multiply both. So when you have to multiply both, you need to pick one variable. And again, it doesn't matter. Okay, eliminate x's first, eliminate y's first. I don't really care. Okay, you can pick whatever you want. Again, a good way to help you decide is go with the one that has the smaller numbers. Now, be the x's, not by a lot, but the x's do have smaller numbers. So I'm going to take the top equation and multiply it by how many x's are on the bottom, which is 5. I'm thinking about what that's going to give me. That's giving me 35x. So in the bottom, in order for the x's to eliminate, I need negative 35x. So I'm going to multiply it by negative 7. Now, if instead you multiplied or try to get the y's to go away, you're going to multiply by different numbers, and that's okay. Okay, it always works out to be the same answer if everything goes correctly. Now I've got a bunch of distribution. So 5 times 7, that's 35x. Then I have 35y as well, and that equals 90. Then negative 7 times 5 is negative 35x. Negative 7 times 8 is negative 56y. And negative 7 times negative 29 is 203. So the x's eliminate. When I add the y's together, I get, what is that, negative 80, 91y. And it equals 90 plus 203 is 293. And now to get y by itself, I divide by negative 91. Making this y equals, that didn't divide out nicely. Did I make a mistake somewhere? Did you all get nice numbers, Gemma? And it worked out? So that means I made a mistake somewhere. Yeah, what? Oh, this is 70, not 90. That's why. Yeah, that's supposed to be 70. There we go. Okay. Okay, that works out much better. Now I get y to be negative 3. Yeah, and my multiplication was off, okay? And again, that's going to happen. Now, what's going to happen, and some of you are kind of getting this habit already, where you're like, if I get a decimal, it means I did something wrong. Okay, so some of you are already getting the habit. If you get a decimal, you're thinking something's wrong. Now, for the most part, I want the numbers to work out nice. But our answers can be decimals. So really what that should trigger, if you get a decimal, just go back and check your work. And that's exactly what I did. I'm like, okay, did my multiplication, am I doing that correctly? And I wasn't, right? 5 times 14 was actually 70 and not 90. Okay, so now that I fixed that, now I'm getting that right number. Okay, so decimals, if you get them, just go back and check your work. Don't assume you're wrong. Okay, yes, most of these are going to be whole numbers, but it's still possible we get decimals and or fractions as our answers. All right, now they have y. This is 7x minus 7 times negative 3 equals 14, and I can solve for x. So this is 7x plus 21 equals 14, and then I can minus 21 and get 7x equals negative 7, and x equals negative 1. So negative 1, negative 3. Okay, I'm going to do one more, and we can skip all the rest. We're going to flip this over to the back side. If you did number 3, great. I'm not going to go over it. I want us to do number 5. Because anytime 0 shows up, that tends to throw us off. Everyone do number 5 again. All that I ask is that you try it. Does not need to be right, but you need to come up with something. All right, so the main reason I want to go over number 5. Anytime 0 shows up, that tends to just confuse students for whatever reason. Okay, but it doesn't change what I'm trying to do. Still trying to eliminate a variable, and I first focused on the x's. So I'm like, okay, I'm going to take the top equation multiplied by however many x's I have on bottom, which are negative 24. Negative 24 times negative 9 is positive 216. So I'm getting 216x and 216y. 0 times anything is still just 0. Then the bottom equation, I multiply that by how many x's are up top, which are 9. That gives me negative 216x, negative 216y. Everything eliminates, making our solution 0 equals 0. That is a true statement. And thus we have infinitely many solutions. And we're going to stop right there for today.